master's in Italy, I went to Germany because I got a job offer in Germany. So I started my second step of my career, I would say, after Maruti. I started working in Germany. Different projects I have done till now. It's been almost 7 years now as working as a professional in the design industry. So my domain has now become completely like car design, automotive design. I mean, there is technical engineering side also, but I would say 90-95% is all totally purely like car design, creative side. So this is the brief about me. So today, as you all know, the title of the topic or the session is like to talk to you or to share my experiences, my knowledge about career opportunities in the automotive design industry, and basic of automotive styling and clay modeling. So here in India, generally it's called like automotive styling. So it's like very common term so that people can understand or get an idea what is it all about. So in professional or in if you say specific, it's like automotive design. You can call it transportation design, and then you go to wider range, then it's called industrial design. So it's not just automotive then, because when you say automotive, it's all related to automobile or any kind of mobility. Transportation mobility means it can be like a bus, commercial vehicles, two-wheelers, like that. Yeah. Now we have like flying taxis also coming up. So whatever makes the move that comes into mobility or automotive or transportation. Yeah. So let's start. Let me go to the second point. You can also write your comments, whatever you feel in between. I'm also looking at the comments also. So I'm going to share you now a screen. Maybe I do it later. So let's go to the second slide first. Yeah. So here I have made the points like how would we proceed further. So I will start with the introduction, like about automotive design and engineering, the differences, is there a difference or how they are related? And then I will give some idea about automotive design engineering career perspective, like maybe you guys have questions in mind, like after doing automotive design engineering, what we see as a career options. Yeah. And then second is like process, how an automobile is designed, styling, you can say. Yeah, what are the processes involved in styling? Step by step discussion I will do. I won't go too much into detail, but I would like to give you more idea regarding by giving examples of some images, so you can have a look on the pictures, and then some videos, small videos for 5 minutes each, so you can clearly see what I mean. Yeah. Then we'll talk about current trends. What is it going in automotive design in general, or you can say automotive industry in general, trends and technologies. And in the end, we'll see career perspective in automotive design field. So I will tell you both automotive design engineering and automotive design field career perspective. So maybe some of you have passion about going into in design field later on, so you can decide likewise. So let's move further. So I will start with this. Okay, engineering and styling. Is there any difference, or are the same, or how they are related? So I have put a picture. It's a little bit on the lighter side. So just to give you an idea what I'm trying to explain or what I'm going to speak out. So don't go completely by the picture. It's just like to make you feel lighter. Yeah. So to say in one sentence, engineering and styling complement each other actually. So you cannot differentiate into two different categories then. You have to take both of them all together at one point, yeah. So engineering and styling go side by side. Yeah, you cannot ignore any one of them. So in the picture, if you can see the first image, it's like engineered. I mean, of course, there is a car. Yeah, there is a good-looking car, but until unless you don't see the second picture, you can't say that's good looking. Then you come to the second picture that is more exaggerated in appearance and styling. Yeah, so that is what car design is. So as you see, I have also written there in the presentation on some text. So there are two kind of categories, like people who make the car function. They manufacture it and they make it function properly. There are different technical parts in there. Yeah, so that is like more practicality and technical possibilities. They are people who do it. So they are like automotive engineers in general. And then there is a people who are responsible for the aesthetic values of the car, like how should the car look like, appealing factor in the car. So they are the designers actually who work with the automotive engineers and both together bring a stunning product, I would say. So basically, designers work in three areas: interior design, exterior design, and the color and trim department. So I will explain you later in detail what are all those departments and how they work. Yeah. So So let's start with the automotive industry and automotive design engineering. As I explained, automotive design engineering is a specialized domain in mechanical engineering. This is all you know, yeah. And it has really a very promising career options. I mean, believe me, as far as my experience is there, I mean, it's not too much, okay, but I have seen a lot of things going on in around till now, as I have been working in different brands projects. So every time it's updating, every time it's updating. So you cannot stay just quiet, and you have to keep updated yourself also what's going on in automotive industry. The technology is coming and innovations going in around, new possibilities people are finding. Yeah. So imagine like this. So every component system in the vehicle or a car or an automobile serve as a professional field in the automotive industry. So every component system is itself is a separate department if you see as a career point of view. So you can imagine like how many possibilities are there in the industry when you join the industry, as you cannot just stick to one option. So you study a lot of things in automotive design engineering, and there may be possibility like you have some inclination towards some specific program, specific system, the engine, the transmission, the fuel system, the suspension, the vehicle dynamics, and etc. Yeah. So you have a lot of possibilities relating to every component system in the automotive design engineering as automotive industry. So I will come to some categories I have made. I mean, this is not everything, but some of the main points as a career point of view. So so take example, for example, in an automotive company like OEMs, I will talk first off, like original equipment manufacturers, Maruti, Tata, Mahindra, Renault, etc. So they have broadly many departments, but automotive design engineering is mainly concerned with some of these top 5 or 6 categories I have categorized here. So research and development, then we have quality control, then we have supply chain, production, of course, then product planning and control. It's called PPC. Yeah. So research and development. So some of you have a very keen interest in research and development. Some of you have good skills with the communication with the suppliers or say marketing side. Yeah, some of you have great interest in managing things with making things possible. Yeah, so some of you have interest in managing people. Yeah, and make things happen in a proper way, in a strategic planned way. Production and then production planning and controlling. It's called market research and what products need to be launched, etc. So as I have highlighted here, let me bring the pointer in. So I hope you can see this pointer in here. Yeah, okay. I was just trying it. It's going good. So research and development, is you can see you have engine design, you have body design and development, you have engine testing, you have transmission design, you have fuel system, you have suspension and brake design, you have vehicle testing, you have vehicle dynamics, material engineering and material testing, then battery management, package layout, and vehicle chassis. So these are some of the titles I have given. So you get those many fields in research and development only. So you can imagine how broad possibilities are there. Engine design is not about designing CAD modeling or something like that. It's CAD modeling there, but you have to do calculations about the performance. You have to talk about or do research about the output, the horsepower thing, and the RPMs, the torque, everything. You have to do it in engine design. So that's in engine design. So whenever term comes in design, that doesn't mean like you have to do something creative or drawing or something like that. It's not like that. You have to do some research calculations, based on different parameters. You have to study parameters and bring out the best product, best output out of an engine. That's in engine design. Body design and development comes regarding the body. Let's talk engineering point of view. The parts which you don't see with naked eye. When you sit in the car, you see the exterior surfaces. If you see inside the car, you see the dashboard panel. You don't see what's going on behind. Exactly the same thing in the seats or in the pillars, A pillars, B pillars, trims. Maybe these terms are new to you, but they are the parts. When you sit inside the car, you see it, the plastic parts. Yeah. So also from the outside, when you see the car, you don't see what's behind the door, or what's behind the exterior surface of the door, and from the interior plastic surface. So there is a lot of mechanism going on. So that's called body design and development, like how the panels are there, or what's there in the panel, how you will you fit the mechanical system to work around. So that's in body design and development. Then we have engine testing. So as the name suggests, you have to test the engine, the performance you have to test, and if there's some feedback, you have to redo it again, to change some parameters, or if the parameter affect, some block design change in the engine, you have to do it. So transmission design is the same. You have to bring out the best output out of the transmission. How will you transmit the power from the engine to the transmission and to the wheels? So to make run the automobile. Yeah. So transmission design, we have fuel system. So like this, you have many systems there. So every topic covers itself a career position for you. Yeah, vehicle dynamics, you have to see a lot of forces. When you are in the real world, you have a lot of forces going in around the movement of the car. So that comes in the vehicle dynamics. It's really nice field also. So battery management, because now we have a lot of electric cars coming, so in that sense battery management is coming up now. And then package layout is always there in the very beginning when you talk about making a new product or existing product with some changes. You have to do the package layout. Yeah, then you do some 2D drawings also there, like where the hip point for the passenger or the driver, all these things. Yeah, the vehicle chassis is there. So likewise, quality control is all about quality and testing, quality assurance, getting the feedback from the customer and implementing the changes. Sometimes you hear in the news, okay, Tata called back these many vehicles because of this problem. This comes in customer feedback and quality control. Then you have to check everything there, surface inspection, you have to do material testing and all. Then supply chain is absolutely about dealing with the communication and making an effective relation between the proper supply of the parts, the components which runs the production. Yeah, it is very critical actually. And then production, of course, you can be a production engineer. Yeah, you can be a supervisor in the production line. You can be in the automation department. Automation means where you have to do this automation of the system in the production line. For example, some of the jobs are done by the people working the production line, and then maybe you can replace them with some automation system. So where you save the time, the fatigue in the person working in there. So there comes the automation, and you have a lot of things going in around. Product planning and control, as I said, it's all about like which products have to be there, how they have to be planned to run the production. Likewise, so they have different parameters to decide on this product planning and control, and this department actually decides like which product has to be done and how it has to be done, and then it gives its inputs to rest of the department, and simultaneously things go on. So this is very brief. I have given you, as far as my experience, what I have seen in the industry, yeah? How the companies run, and then you can see like which area is your interest. Then you can just focus on that. Maybe when you go in the placements, you have to have good knowledge about these at least these points what I have told you, at least to know actually like where you stand or where you have the knowledge about the company working. Yeah. Okay, so I hope you have now a bit of idea what I wanted to explain there. So let's move. Okay, so let's come to the automotive design. Yeah. So because this is my domain, major domain, so I will talk a little bit more about it, not into the details, but brief like overview of the same. So both automotive design engineering and you can call automotive design is like both have creativity and passion. Without passion or without interest, you can do anything. Let it be automotive design or anything else. So most of the things are like you have to relate how interested are you in that or how much you want to do in that. Yeah. So that's all about creativity and passion. So in automotive design, you have to be like more passionate because it asks for a lot of patience actually, for the results. And imagine in the engineering studies, you have exams, you have to write things, you have to write formulas, derivations, and all those things. In automotive design, you don't have to write exams like that in a sheet of paper, writing formulas, derivations. You don't. You have to do, I think, maybe 5% of that like that. 95% is like you have to show, you have to present, you have to sketches, you have to make a presentation in the graphical representation of your thinking, what is in your mind and what you did in the sketches, 3D models like that. So in automotive design, presentation goes like that. Yeah, in engineering also we have like major projects, minor projects where you would be showing your models, so you can take that part as majorly 95% in the form in automotive design. Yeah. So let's go. So I start with this process loop here. I have shown here, for example, design process, like how nobody, I mean, of course, some people have idea like how the car happens to be designed before it comes into production. And this is the process actually. There is like a lot of many steps in between, but these are the major steps. So I will read it out. You can see in the presentation like market research, uh, ideation, conceptualization, digital modeling, then comes clay modeling, then virtual reality. This is a new thing happening a couple of past years ago. Design presentation, and then class A modeling. So what is market research actually? So as the name suggests, to start anything, you have to do research. It's a very layman language. You have to do some research, background homework, background study, what I need to do, why I need to do, and how I need to do it. Yeah. So what, why, and how, these three things, market research. So based on the product portfolio, project brief, and segment, you get a project brief in the beginning, like what has to be done, how has to be done. So we start with this market research, and you take also benchmarking of some existing products there. So this research makes a base for ideation sketches process for the design of the car. So for example, you want to design a car, you have to do market research, like what is my customer. Yeah, you have to select the customer group, and then based on that you prepare a base, platform to start your creativity, like what's in your mind. So for example, if I want to design a car for a rich guy, he's like a lot of money and he want to design a car, so I have different approach. Yeah. And then there is a group of people who is like daily users, going office goers, shopping goers. Then I have different approach. So this way I start my sketches. So that is the second step, where we call it ideation or conceptualization. Yeah. So keeping target group or the brief of the project in mind, we do extensive sketching there. 100,000 of sketches we make, small sketches, and then refine them, present them to the board, to the managers. So we do sometimes design clinics. So design clinic is kind of like invitation to all the people in the company or in the group. So they come and we just hang out all the pictures on the wall, and then or maybe nicely sorted out presentation sheets where they are giving options A, B, C, D, like which one you like. We make kind of poll there, voting which one you liked, why you liked, something like that, multiple choice questions and all that. And we take a kind of opinion from the public. So this is done. This is a part of ideation. So out of these 100,000 sketches, in the end, after so many revisions and meetings, or you can say presentations, these are cut down to like maybe 3 to 4 key sketches. 3 to 4 key sketches means these are the sketches which will be the backbone for the coming car or coming product. So that image you have to take in mind and then develop further. So then comes digital modeling. Digital modeling is simply 3D modeling. So sketches was just in 2D, then it comes to 3D. So in 3D, you have to develop CAD model, physical models. So maybe in your course right now, maybe you are doing some CAD modeling in SolidWorks, Pro-E, Solid Edge, and then CATIA is always there. Yeah. So these are the basic software which are done in engineering generally. But in car design, we have a little bit different. So they are also there. CATIA and SolidWorks are also there, some of the companies. But car design is like we talk about not the solid models there. We have surfaces, the skin of the car. So when you see from the outside, you see the side body, the front, the bonnet, the roof. So we don't give like maybe 500 millimeter thickness or something like that. We have to design the surface's skin there. So it's more into surface modeling. So I would say solid modeling versus surface modeling. Yeah. So this is digital modeling part in car design. So we are doing surface modeling here mainly. So what we do here is like we make 3D model out of the sketches. Based on the sketches, we have the side view, front view, back view, or the perspective isometric view of the sketch, and then we use it as an input to design our car in 3D. So this is concept modeling stage. Yeah. And then after the model is ready, we just feed it into the milling machines. Because we have big milling machines, we do clay modeling. So clay modeling, I will explain a bit in detail. So later on. So the 3D data is fed into the machines, milling machines, and they are milled into clay. So maybe you are aware of what is it, clay. So clay in industrial design or in automotive industry is kind of industrial clay, we call it. So it has like specific behavior in a certain temperature. Like for example, 60 degrees, you just keep it in 60 degrees. So whenever it becomes solid, and then you can use the clay to make different shapes. With hand, you can squeeze it, you can deform it, and you can apply it to the surface, and you can use different tools to do the finishing thing. So this is that kind of clay. Then comes virtual reality. I mean, this field is not new, but it's coming up very aggressively in the use nowadays. So what we do is you have seen this VR. When you go to see some 3D movies or something, you have this headset. So this is the same thing. It's like virtual reality. You put on the headset and you just have the real environment. You have your data feed into the system, and then you can relate. You can just upload the data of the car interior, exterior, and then you can upload the environments, and you can see the realistic feeling of the environment with this VR headset. Yeah, after all doing all these, when everything is prepared, then we have this big design presentation. So we have like big bosses coming in the design presentation, and we can show them the 3D, the physical model of the clay model, 1:1 scale. The real car size model is there in the studio, really finished like a real car, and they can see that. They can also see the 3D. They can also use the VR technology to to analyze the design in the real environment. And then when everything is done, for example, okay, the design has been given a green signal from the management and has been approved, then we go to the production side. Okay, let's move ahead to produce it. Then we do the Class A modeling. Class A modeling is a part of digital modeling, but it is like more refined, more quality, highest quality standard. So when you go to the production, you don't have any chance of mistakes. Yeah, digital modeling is the stage concept modeling where we don't bother too much about like that finest quality because it's design proposals you are giving in. So when everything is freeze, then we do class A modeling, and further it goes to the production departments, and the process is like to and fro, feedbacks coming in, changes, feedback coming in, changes. So this is a known thing, yeah. So I hope this brief you have understood quite well, yeah. So let's go to talk about the processes. So market research, I mean, I have put some steps how we do it. So we have car research, clinic surveys, and for focus group, all those things. Online insight communities, we have market entry and sizing assessments, we do competitive analysis, benchmarking. So there is a sheet like which are the cars sold in the world in most numbers, so like that. So you can see Corolla, Ford F series, all these things. So this is a part of research what we do. Then, for example, domestic sales, if we talk in Indian scenario, you can see in the passenger vehicles, the two-wheelers are the most sold in India, and then the passenger vehicles. So this is a part of our research, what product we should bring in like this. Yeah. Yeah, you can see here in the graph, 80% is two-wheelers, then 13% passenger vehicles, and you can see the models, Baleno, Alto, Wagoner. Are we going to make a hatchback or SUV? What is the market demand? For example, like that, we do it. So, how is India doing about car buying things? So most of the people in India are like they have multi-car homes. They have like two, three cars. Not most of the like there is a group of people that have multi-car homes, and there are a group of people they use as combined car pooling, car sharing thing. Yeah. And nowadays, as you know, this battery electric vehicles are coming up, so we can see the share like 0 to 5% are like medium or heavy commercial vehicles, and then we have like 5 to 15% as SUVs, 15 to 25 light commercial mid car, compact cars, and then 25 to 35 is motorcycles and three-wheelers and two-wheelers. Yeah. So this is how we do it. As I explained, then we do the competition research, like what are the competitors, how they are doing, how is their trend, design, styling, clues. We take it from there, and then we do the ideation based on that. So concept generation, the second step I told you, this is few works of mine. I wanted to use my works to show you also how I did it in my time. So we have some images, design inspiration images, and then we start sketching all those things. So this was a project. I did it like that. So you have a lot of sketches in there, and then you have the renderings. These are the Photoshop renderings, actually. You can see also the two-wheelers like that, and then you do a lot of sketches. You do a lot of colors used with your hand, manual, and then a lot of Photoshop also 2D sketching. So this is the part of ideation. You have a pencil or pen sketches in the beginning, and then you do some coloring to give it realistic or 3D feeling. Yeah, so you can understand how the surface is going. So you can see there are white patches on this, and some of the colored sketches there, white and black patches. So it is all about light, shadow, and reflections. Yeah, so like that it goes on. So sorry, yeah. So this is a part of sketching and development in 2D. So Photoshop rendering, you can see these are all the example of Photoshop renderings also the interior, how do you do it. This is just 2D, these all the images are 2D. So you learn Photoshop rendering in that and you do it, and based on these sketches you move further to make it in 3D. So this is the example of a project I did with one of my friend. So you see here we have sketches in the beginning, and then we develop the 3D. The second image on the top right here, this one. So these are all the 3D model screenshots. And then you come to the lower corner here. These are the 3D renderings, we call it. So you use the 3D model to give them material shaders, realistic material. There are softwares in automotive design where you give the material shaders to the model and you make it realistic. And these are the some advanced renders where you put the real background, real scenario world, and then you put your car, your model in there, and so these all contribute to the design presentation. So these are all the contents of what a design presentation will see. So how you do it, and believe me, there is like so much talent going in around. Like you see like extreme quality things on these packages, sketching, 3D modeling, and then 3D rendering, and we call it CGI, computer graphics imaging. CGI, where you see a lot of companies giving their posters, the big hoardings. So they all do CGI Photoshop. They have photography in there. The Photoshop work, after touch-up work is sorry. So I have shown here digital modeling and 3D rendering, two screenshots. So on the left, this one is a screenshot of the project I showed out of the 3D software. The software we use is mainly Autodesk Alias. Autodesk is a big company in softwares, and Alias is the name of the software. And on the right corner is Autodesk again, and this is 3D rendering software which is called VRED. So these are two examples. So I would like to share you the screen to show you how does it look in the software and what I mean by the 3D modeling. Just so wait a minute. I will share my screen here. Yeah. So maybe could you, any one of you can write in the comment box if you can see the screen movement. Can you see the model there? So this is the software I was talking about, and this you can see there is a model. So this was a Lamborghini personal project. I have done it. I have modeled it, designed it like this, and this is what we do in 3D modeling. Yeah. So this is what I mean. So I would show you here the lines. Now you can see the edges there. So these are all surface modeling. Yeah, I was talking to you surface modeling thing before. There is solid modeling and then there is surface modeling. So for example, if I pick up this surface for you, and maybe for you, and I will show you what is inside. You see? So you see there is nothing behind. It's just one surface, zero thickness. And then later on when we go to production, this work is done by the engineers. Yeah, engineers, they do it according to the production parameters. If you want a 3D print or something. So this is the surface modeling, and if you open the technical things in here, you see there are a lot of control points in there. So we have to design surfaces. You cannot just pull out, and I will show you here. So for example, this control point, I will like this. You see, you can move it like this, and you see the behavior change in the surface. Yeah. So this is how we do it actually. In design, you have to do 3D modeling based on the design flow. It is, you cannot just do it randomly here and there. So this is the Autodesk Alias software. So I think 70-80% of the companies are using the same software to make their models. Yeah. So I hope you got an idea how it works. Okay. And the second thing I would, so the same mode, how do we render 3D render in it? So this is another software. It's called VRED. Yeah. We call it visualization, 3D visualization. Yeah. And it's the same model before I showed you, and you see the difference in the shaders and the reflections. This is more realistic. You are giving the real 3D feeling in here. So we have, for example, if I show you here, just to show you an example. So we have different materials. You can see here, we have different kind of materials. And then if I pick and drop, you see, there's a material, is a metallic body paint, and we just drop in here, and then it changes the color like this. So this is what I mean. I mean, you have different materials. It's like rubber, plastic, and everything else. Yeah, glasses. You have glass effect. So it's a long process actually. It takes a lot of time. For example, if I want to make a high quality JPEG of this, maybe it will take a couple of hours to make one single image. It depends on the performance of your machine, on the configuration of your machine to process these kind of images. And then after making the image out of this software, we have further development in the Photoshop. Then you do some Photoshop touch up, some fancy things, I would say. You do it in Photoshop. Okay, so let me close this. Mm, all right, so back to the presentation. Let's see, where is it? Just a moment, I'm just sharing the presentation again. Okay. Okay. So I hope you are seeing the presentation now. So after this, let's talk about clay modeling. Yeah. So I will talk a little bit more about it because this is more interesting and physical. So you can see the pictures, yeah, the brown thing. So this is the clay, actually, industrial clay. As I mentioned before, this clay, you can deform it but by heating it to 60 degrees. We have big machines in the studio. We call it clay oven. Yeah. So we put the clay. They are like cylindrical foam bars of the clay, and we get it from Japan and Germany most of the times. They are the two big suppliers of these clay all over the world. So we do, based on the 3D model, we just mill it. You see here on the lower bottom, I will just do it here. You see this picture here, the car. So there is a basic foam structure behind, and we put a lot of clay on the top so that the machine can load the data, 3D data, and then mill it. So this is how the milling goes in a company. These are the real pictures of the studio. This is not from the studio, but they are in the internet. So this is in public domain. I can show to you. Yeah. So this is how this is done. There's a fine milling from the machine, and then later on the work of the professional clay modelers, the clay designers you can call it. So they have the job to finish the model like smooth, not too many dents on the surface, and they finish it smooth, cover it with the silver film, silver color film on the top of the clay model to make it realistic, like a silver color car. Also the interior like this. So in the interior, some of the time we have the real parts. So for example, here is the real steering wheel here, which is fit into the structure there. and give it a realistic feeling. So you can actually sit in the cockpit of the car, but everything else is clay. You have the seats, real seats. You can sit down. You have the real steering. You can feel it, the design feeling, you know. So how it is done in the design presentation or design review. You can see in the background there is a door trim there. So every component is done individually, and a lot of time and patience you need to finish them all like that. So this is color and trim. This is another department which is responsible for deciding the colors. So you cannot just pick yellow, green, like this, orange. This is not just, these are just the colors in the layman domain, I would say. But you have color design. I mean, people in the color and trim department, they design the colors actually. They blend all the colors. They test them in the real environment, you know, in the sunshine or in the dull weather, how they would gonna look, the shininess there, the texture, you know. So all these are done by the color and trim designers. They do the coloring design of the car parts, whether it be exterior or interiors, and then they also do work on the fabrics, you know, the seat fabrics, the grains on the plastics. All these things are done by the color and trim design. So it's a big department in there itself, and it's very nice also, you know. So they also do innovations of the materials. They use environment friendly technologies also coming up, you know, recycled materials. So this is a very big and very much opportunistic department, you know. A lot of people are doing color and trim now. So moving further, and this is virtual reality, what I told in my steps. So you see what I mean. I mean, you can see the pictures, yeah. So for example, people do wear this headset and then you can see this is actually the real-time software, you know. It gives you the real-time, it takes the real-time input from the 3D as a 3D, and then telecast it the real environment all around you. So you can feel as if you are inside the car or you are with the car in the outside background also. So this is one way of analyzing the design, you know? And then you can see the real behavior of the surfaces or the parts in the real lighting environment. And these are some screenshots like how the design presentations are. So there are different ways, you know. So if you see the lower bottom picture, so there is a big screen and there you have the model there. So this is the digital presentation where you see the digital model there, you know. And then later on, if the management of the company decide to make a physical model 1:1 scale, then you have the physical prototype there. You see there. So you can sit in there, you can see the reflections of the light over there on the body. Yeah. So this is how the presentation is done. On the computer screen, you can talk about this should be like that, this should be changed, you know, like that. And also the color and trim there. So these are the screenshots, and these are the real industry pictures. So the left right corner is the BMW design, also the bottom, and then the second picture is from Audi design, and this is I think from Renault. So these are some insights of the design studio, like what we do here. So I will talk about future mobility later. Now I would like to show you some videos. I hope it should be nice and working. So there you could see what I explained by speaking or by pictures there. So let me do it. Just a moment. It's coming up. So I hope you can see this VLC media player screen in there, yeah? If not, please text me there and then I will have a look. But probably it's there. So let me play this.
This vehicle is Porsche's answer to the questions associated with the future of electric mobility. Our Porsche Mission E. This concept car is a truly fantastic challenge for us because it's our first electric sports car. You're commissioned to do a job, in this case, to develop a 4-seat sports car with an electric drive system. Then you start producing sketches as a team. And then the sketches are shown in presentations that are made in specific intervals. After a sketch has been selected, a 1:3 scale model is produced. When you're defining the basic concept of the vehicle, you start out by setting its proportions, and then you figure out how to actually build it. We built a basic chassis and then combined it with electrical components from the Boxster E. So in the end, we had a demonstration model that could be driven. It was very important to us here to create typical Porsche proportions. We were able to design an extremely low front end because there's no engine in the front. We also didn't need to have any huge air intakes, so we were able to design everything in the front in a very clean manner, almost a bit like the old Porsche models from the 1950s, 60s, and 70s. We then mixed the whole thing with the wonderful shapes of the 919. Creating this combination of a race car and a carefully designed vehicle was the best part of the job. One thing we thought about, of course, was how to attractively integrate an air curtain that would guide air around the front wheel. This led to the front-end design we chose, which, as one can see, has the classic round Porsche nose flanked by 2 intakes that let air pass under the headlights towards the wheel arch. First of all, the vehicle is clearly recognizable as a Porsche. But we designers wanted to go a step further and see how the Porsche design language, especially a Porsche electric design language, might be developed further. Our intention here was to also be somewhat provocative with some parts of the vehicle, but nevertheless, just one look at its proportions and the general design is all it takes to see that the vehicle is clearly a Porsche. We also addressed a couple of strategic issues that are very important to us. The 4-point lights in the front were important to me. The arc of light was the main issue in the rear. For us, the door concept is a typical sports car design, one without a frame for the first time. Convenient entry in the rear is ensured by rear hinged doors, and the fact that there's no B-pillar makes for perfect access in the rear. The vehicle is very special for Porsche, as it's a new icon. One of our most well-known cars is the 911, of course. And this vehicle will carry into a new era all the things the 911 has been famous for throughout the decades. That's why we came up with some very special things for the interior as well. We tried to focus on various key aspects. One of these being the fact that we wanted to achieve an entirely new type of interaction with a vehicle. We utilize gesture and eye recognition systems here to enter commands for the car. We tried to create a new type of holographic display. You can input commands on the front passenger side and via the center console. This, in fact, is already a standard feature in the 918 today. Besides that, we did something new with the seats. We've got lightweight seats that are bucket seats naturally, and these have a fairly sporty design. Then there's the craftsmanship, of course. The quality of the materials used truly conforms to the highest standards, which is just what you'd expect from a Porsche.
So hope you all watched it and liked it and understood what I mean to explain. Okay, so I would like to show you, this was one of the car industry. There is another one I would like to show in the two-wheelers, So you have the idea.
Ducati, the most alluring Italian temptation on two wheels. Elegant design, Italian passion. Introducing Andrea Ferraresi, head of Ducati design. Under his leadership, a Ducati gets its unique sporty design. They're created here in this room in Borgo Panigale, Bologna. Quite traditionally, almost like a painting.
We start with this black and white pencil-made sketches, then we scan them, we load them in a computer, and we find them in Photoshop for the final presentation. After made sketches, we arrive at the second stage, which is the so-called proportion model. This is not a real bike, it's a maquette, one-to-one scale maquette. After that, we have the clay model, and after the clay, the final stage, the so-called clinic model. And of course, at the end, we have the real bike.
Going from the sketch to the clinic model takes 2 years. 2 years during which his 20-member team designs things like a Ducati X Diavel, for example. Color and form are defined down to the smallest detail.
The main philosophy is that our motorcycle must be real everywhere. So no baroquism on our fairing and no unnecessary part on our mechanical layout. This comes from the racing field, our racing heritage, to be as much sporty as possible.
Perfection, love of detail, elegance, sportiness, and very important, emotion. That's the DNA of a Ducati. Added to this are Italian flair and aesthetic sense. A Ducati will always remain a Ducati. It's more than just a motorcycle. Ducati is a feeling.
The guy takes inspiration from everywhere, from the racing, from what the customer realize on their own motorcycle, and we take inspiration from nature, from fashion, from everywhere.
Ducati and Audi. Not only have they been a team since 2012, they also have a lot in common. The love of their products, the pride and passion that both Audi and Ducati employees put into their work.
I think that the similarity between the two brands' design comes out and are based on the common DNA, which is a sporty DNA. So both design are adrenaline, muscular, fluent, elegant. So for both brand and recognizable, of course. So both brands have a clear sports design.
Ducati recently won one of the world's top prizes for design, the Red Dot Award for the X Diavel. Ducati is and remains the most alluring Italian temptation on two wheels, thanks in part to Andrea Ferraresi and his team.
Okay, so I hope you have enjoyed it watching. So let's move further to the presentation. I'm just sharing again the presentation to you. Okay, so here is. So let's move further. After the process discussion, let's come what's going in around in the future mobility scenario right now in the automotive or transportation segment. So as you can see, I mean, if you take an example of a proper city, for example, Munich, Germany, where I am, where the headquarters of BMW are in. So there's a great percentage of the people who just take a single car, So there's one guy taking the private car and going around. Yeah. So this is around 30 to 40%. I'll just use my pointer in here. So this is 30 to 40% the people who use private cars. Yeah. Then there is another mobility solution, like they share the car if they're going the same office, or they do blah blah car system. You just there's an app-based mobility solution where people in the same route they can just pool in the car. Then you have public transport is also 30-40%, and there's micro mobility coming up in the cities like in here. So you have the bicycle and you have this electric scooters. You just stand in, you have the battery system, accelerator and brakes. You can just roll in by standing there for short distances. So this is what is going in around. And then we have the flying taxis. This is something big actually coming up or happening up. There is not really anything in the production or in the functional, but things are coming up very quickly. There are many companies in Germany itself which are already working on. So one of them is Lilium. Lilium is a company in Munich, headquarter based in Munich. They have already test flight 2 times, I think. I will show you maybe later one video about it. And there is one company called Volcopter in Germany itself again. And there is Airbus is also doing collaboration project with one of the biggest design firm in Italy. So it's called Etel Design. So yes, flying taxis can be the future. Maybe in the coming 4 to 5 years, we can see maybe one of them functioning, because Lilium has said maybe 2025 they will make it operational. They have the target in there. Okay. So also apart from this, a lot of things is happening in e-mobility and autonomous driving. So e-mobility, as you all know, is all about electric. So to leave behind very less carbon footprint, we have this e-mobility, electric cars coming in. Of course, Tesla. Yeah, Tesla is a big name in the electric mobility, which is leading in the front. And then we have other brands also which are all also doing electric cars. And autonomous is something which is like automatic. So things are going in automatic and around. If you want to drive by yourself, you can just do the driving mode. If you don't want, so maybe the car takes you wherever you go. So these are some examples, existing show cars or the already done. They are big names. If you see here on the right, left, top corner here, the pointer is. So this is the vision concept from BMW. Is you see how the car design is going on and how the automotive is coming up. So this is one of the concept cars. It's not into the production, but it's just BMW wanted to show the future, how can be the future. So this is one example of the autonomous. And there on the left corner, there's Volkswagen Group, which showed this concept in there. And then also Mercedes Smart, they have a sub-brand segment called Smart. And on the right bottom corner is Byton. So this is a company, is a Chinese startup. They have also base in Munich area. So these are the companies which are doing autonomous and electric cars very extensively, and maybe in the future, a couple of years, we can see some existing production model from them. So okay, guys. So in the end, we are towards the end, and I would like to share some thoughts about career perspective in automotive design. So you see the difference. I mean, automotive design engineering and automotive design. So you see the possibility of career options. So in design, to be honest, I mean, you have little bit limited options of the job profiles. So we have like maybe within 10 steps of designing a car in the design studio, inside the design studio. And in automotive design engineering, you have so many things. So many career profiles can be there, as I showed you in the previous presentation. So here you can see, so you have creative designer profile who makes the sketches, because if you are a guy who can do everything, but in the industry, in the real life scenario, you are not able to carry out all the functions altogether. So in the industry, in an automotive design company, in a design studio of a OEM, you have different people. It's a group of people. It's a teamwork always everywhere. So there is a teamwork. So you have a profile called creative designer who is responsible for making 2D sketches, Photoshop renderings. Then there's a digital designer, a guy who takes the input from the designer or the designer's work together to make a 3D model, in different softwares, as I showed you before. And then there is a visualization artist. So these are the names of the file. In general, we call it like this. Yeah. So these are the people who work closely with the team to bring up the design of the car. Yeah. And then we have a color trim designer there. Yeah. Then we have CGI animation. They make the nice pictures, for marketing, advertisement stuff, all these things. And there is also clay modeler, as I said. So we have like maybe 10 up to 10 or 8 to 10, I would say 8 to 10 profiles, job profiles, after doing automotive design as a professional course, or you can say our training, whatever. So 8 to 10 profiles, I would say. Yeah. And in automotive design engineering, you have lot many. Yeah. So it depends on the interest, like what is your passion, what is your interest. You can choose both, or why, or likewise accordingly. Yeah. And I hope after this presentation you have a clear idea like how they are related, how the process goes in. Yeah. So I hope I have covered it nicely to make you understand. So this is more or less the end of the presentation, towards the end of the presentation. Yeah. So okay guys, so this is my email ID here. Sorry about it. The later words are on the bottom. So you can, if you have questions in the future, if you want to take some guidance in future, you can contact me on my email, which is here on the bottom left, bottom right, sorry, narendra.automotivedesign@gmail.com. Yeah. And these are some of the links I am available. You can see my work online. Yeah. I am on Behance. Behance is a portfolio platform for the creative designers. Yeah. Then LinkedIn, everybody can go to the LinkedIn and then meet there. Yeah. So thank you, everyone. It was really a nice pleasure to talk, to discuss all these things, whatever I have learned and experienced. And I would like to thank the UPES faculty team also for organizing this, and all the participants. I could see like more than 100, which is really nice. And I really enjoyed it because this is my first time like this. And I would, towards the end, I would also like to show you some other visuals to make it finishing nicely. So let's see this one. I will open it now, which is regarding like in the design, how the students or the universities conduct a thesis project or design degree show. So what is next is I'm going to share my screens now. Yeah. So this way, also in between, you can also put your questions in the chat box. The chat is open for you. So, okay, let's take the questions first because I have already got the questions. Yeah. Good noon, sir. What skills industry is looking for a position in research and development department as a CAD, CAE engineering? In most experience, they tie us to do MS rather than letting us join them. Okay, so this is Nishkars Gupta. Yeah. Yeah, it's a good question actually. So CAD, CAE engineering department is basically, if I told some of them about CAD. So CAD modeling, as I said, is all about like body structures, how will you design them, So it's a part which helps in the creative design also. So while you design the surface of a car, you need some base component because there are components behind, and there is a test of the components, like how much strength they need to hold on, and many other parameters that depend on the strength analysis we do it. So they all come together in CAE. So you have to analyze the strength, the stress and strain level maybe you have also studied in your course all those parameters. So this is covered in CAD and CAE engineering. So you talked about skills. So there are departments for sure. Maybe I missed this one actually. This is a good, very good question. Thanks for it. So this is CAE department is also there. So which takes care of all these things, you know. So you have to change your design, or you have to change your material parameter, whatever is there, based on the analysis results of CAE. And also there is CFD also. So CFD simulation we do it. So there is a big department working on this for sure. Yeah, is in every automotive company doing this, and this is doing extensively because this is very critical also. So I would say don't bother about it. I mean, for example, I don't know what do you mean by like most experienced that tie us to do MS. I don't hear it before. Yeah, so there are departments already working in. So if you have interest and skills, so you can just focus on that and bring up your skills and increase your knowledge in that. If you have interest and skills, and if you are successful in getting that department, you can surely work in the industry. I hope I answered that. Yeah. Mayank Kamboj, good noon, sir. I'm much into engines. Can you please tell how can I proceed further my career in R&D of engines? Mayank, for sure. I mean, there is a big scope in engine also. So engine is a broader category also. What do you want to do in engine is depends. Like there is engine testing, there is engine design. You know, so both ways you have the possibility. So it all depends what is your profile into. For example, what are your strengths? Yeah, so if you want to go to the engine department, there's a big things going on, engine design, the different parameters, the calculations you need to do, how to design an engine, you know. It's not just the word engine, but there are many parts in an engine. Yeah, so this way you can do, and there are many online research journals available. So maybe I would advise you to go through that, make your own research, you know, make your knowledge base very good, because I think you are in third or fourth year students. So it's a good time to make your extra knowledge by making it as a strength when you go for this campus placement, you know. So of course you will not have like, okay, 100% knowledge, because there is always a little bit of difference, you know, when you come to the realistic scenario and the academic scenario. So you have like more realistic approach in the industry, like you are more close to the realistic thing, what's going on. So there you will get to implement what all knowledge you have gathered in practical. So practicality you will do in companies, you know, when you get into the profession. So you can take this as engine design or engine testing, and you can research about it and read about it. And there are many people in LinkedIn, you know, who are doing engine design, engine research. Just talk to them, message them like that, in every field, I would say, in general. So there's another guy, Amit Chetri. Sir, for a student who is interested in pursuing his career in motorsports, how to begin after BTech? Ah, this is an interesting one. Motorsports is itself a great career, I would say. It's a good question. So maybe this is also a good point for team. Maybe in future we can have a course regarding motorsports, because of course the motorsports is going on in every country, everywhere, also in India. Very nice point raised, though. So maybe Shyam Pandey sir must be taking care of this point. I would also give my feedback motorsports regarding motorsport. So as far as my knowledge, motorsports they have special trainings. Yeah, motorsports have different level of adrenaline, not only in like physical activities, but also in their research, and their parameters are differently raised. They have a little bit higher level of endurance limits, parameters. So for example, I'll give you an example. When I got the opportunity to work in Ferrari design studio in Italy for 2-3 months. So I could see they have a different company inside company, I would say. They have a different company inside Ferrari. So it's which is taking care of Formula One, you know. So Formula One, they have different team, they have different engineers, they have different designers. So in motorsports, if you talk about cars, for example, for Formula One, so there comes aerodynamics. That is the most crucial thing. So aerodynamics is a separate department. So you can choose likewise different things which define the motorsports activities, aerodynamics, and then you have like brakes and suspension is also very much crucial. Then you have vehicle dynamics. So these are the fields you can focus more into if you want to go towards motorsports. Yeah. So that's it. And the next is uh, good after how are engineering and design are connected and at an engineering level. So Sambit, maybe you heard in my presentation, I have already explained like how engineering and design are connected because they're of course connected. So engineering is a support pillar for design and design is also a support pillar for engineering. So both go together, you know. So whenever a product has to be designed, there are engineering inputs. Like there are some feasibility concern, you know, if you make something which is not feasible, doesn't make a sense. So there comes engineering telling, okay, this is feasible, this is not feasible. If you want to make it feasible, do like this, do like that. So it's like to and fro process. So both the parties give feedback to each other and then they go together towards the goal. So they are connected there. I give you an example. For example, if you want to make a door, talking about interiors, or maybe, okay, let's talk about the exterior of the car. You cannot make a car out of the package, yeah? You have a certain package which is decided, which is given by the engineering based on the platform. So you have to respect that package. You have to make a design based on the package. So once the design is done, the design goes back to the engineering. Okay, we have this design, we have designed it based on the package, you have to check it. So then the engineering will check the design. They will again find something in there. So they will again give the input. So this is happening like this, yeah, at an engineering level. This is not about package, there are many other parameters, yeah. So in every point they work together, they are never separated, they are always at communication level in a project. I hope you got the answer there, yeah. And the next is Himanshu. Good afternoon, sir. I am a student of BS third year of UPES. It was a great session. Please, sir, want to please take this same session for our design students and will be very helpful. A huge respect for your alias modeling. I want to send some of my work. Thanks, Himanshu, for the kind words. Yeah, I have been in UPS, I think, 2 times before. Also in the School of Design Studies, I have given presentation there. Of course, when I visit India, I will surely love to be giving a session in there. Yeah, so we will arrange it in future with the faculties there. Yeah, so don't worry. I'm sure we will make some session in future. Whenever I'm there, we will do it. So Himanshu, if you want to share some of your work, you can always contact me. I have shared my email in the presentation. Maybe I just keep the slide open for you. So there is the email here on the bottom side. Yeah, so you can contact me and you can share me there. And you can also find me. You can just search Narendra Singh Chetri in LinkedIn. You can talk to me over there and share your work. So, okay, maybe we are running of time. Maybe I take another 5-10 minutes and then we would like to close that session. Maybe we can also answer an email. So it's from Geetanjali ma'am, the time limitation. So we will have to take care of that also. Yeah. So I'll just take one question more and then we go off the session. Yeah. Himraj, hello sir. As you have shared about the eagle design, would you like to share your comment on the potential of biomechanics? This is something what I could not understood well. Himraj, I did not understand your question nicely. So maybe you can write me an email explaining further. Yeah, I will take another question. Uh, Prabodh, so it is a master's degree necessary to take us into some good R&D. Prabodh, no, master's degree is not necessary to take into R&D. I mean, it's all about your knowledge, your skills, your performance, and the education, academics. You know, did you perform? What kind of knowledge you have? So it's all depends. For example, in the placement session, they take the placement and they see your CV or whatever projects you have done, whatever knowledge you have, and you have interviews. So they decide there itself if you are taken into it. They have some kind of idea about you if you are good for R&D or not. So likewise, when you go in the company, you have their introductory period of like 4 months. For example, when I was in Marathi, it was like 4 months. So you will be having 4 months to explore each and every department of the whole company. You spend 4 months there, going 4 weeks, 2 weeks to each department, spend time, learn basics there. And then in the end, there is another in-house test from the company. I don't know if it is still existing or not, but that time it was like that. So you have an in-house test. So it will test your knowledge about what you experienced in these 4 months, and then accordingly you will be giving the departments. So there itself you get the R&D. It's not a big deal. Yeah. So your BTech bachelor's is enough, and your knowledge is enough to get into R&D. It's not like master's degree is necessary. Yeah. So okay, guys, I think that's it, and it was really nice. I thank you again, all of you, to participate, and I wish you a good health. Stay safe and stay at home. And if you have any questions, you can always ask me. Yeah. Thank you, everyone. I will sign it off. And thank you, Gitanjali ma'am, Shampande sir, and everyone involved in the arrangement of this session. It was really nice, and I hope you also enjoyed. Thank you, and I will sign it off now.